So let's take a look at this parabola. The first thing you want to do is try and decide what the vertex is. I mean, that's 2 easy points, I hope, for you on an exam. Start by looking at the inside of the squared term. What makes the inside of the squared term 0? What value of x would I put in here? 2. And if I put in a 2, that would be 0. Squared is still 0 times 3 is still be 0. All that disappears. What would be left?
A -1.
-1. So you can pretty much read off what the vertex of the parabola is when it's in this form. So that's a nice form to have it in, and we're actually going to take the time to put something into that form. Now the next easy thing to get would be the y-intercept. That's where the graph is going to cross the y-axis. Now, how do you find the y-intercept of a graph? Plug in 0 for x, good. Because where x equals 0, that's where the graph's going to cross the y-intercept, or the y-axis I should say. So f of x and y are the same, so it's going to be 3 times 0 minus 2 squared minus 1. So you're putting in that 0 right there. That's going to give us 3 times -2 squared, which is 3 times 4, which is 12 minus 1, or 11. So 0 and 11. That's your y-intercept. So though, again, you know, a couple easy points. It's like 3 or 4 points on a 10-point problem. So chip away, get as much partial credit as you can. Let's keep going. How are you going to find the y-intercept, or excuse me, the x-intercepts?
Set y equals 0.
Awesome, set y equals 0. So, all right, let's do that. This is essentially my y. So I'm going to set y equals 0, 3 times x minus 2 squared minus 1. You've got a lot of ways you could solve a quadratic equation. But because you've already got a squared term like this, I would suggest you use the square root property. Let me demonstrate. We're going to add 1 to both sides. I get 1 equals 3 times x minus 2 squared. And then divide by 3. X minus 2 squared. Now what would you suggest? What's a good trick that we could try right now?
Take the square root of each side.
Yeah, take the square root of each side. And in particular, on the left-hand side, there's something that we got to remember. Don't make Josh do all the work. What do I have to remember on the left-hand side?
Plus or minus.
Plus or minus, thank you. Need that plus or minus. There's 2 possibilities here. So that's going to be plus or minus the square root of 1/3 equals x minus 2. Now I want to get rid of the 2. I'm going to put it on the other side. When it changes sides, what else is going to change?
Signs.
Signs. Changes sides, changes signs. So that's going to be a plus 2 plus or minus the square root of 1/3. Now you could rationalize this. I really don't care. It's good enough to have it like this. So your roots are going to be 0 for y, and 2 plus the square root of 1/3, and 2 minus the square root of 1/3. Your vertex was at 2, -1. And your y-intercept was at 0, 11. Now there's nothing wrong with looking at a graph on your graphing calculator or on Desmos and kind of confirming some of this stuff. So let's see if we can't do that. Let me open up Desmos here. I'll shut these off for the moment. So it's going to be y equals 3 times x minus 2 squared minus 1. And there's several things I want to confirm. So one of the things I wanted to confirm was the vertex. So let's take a look at the vertex. Oh, 2, -1, just like I thought. How about the y-intercept? Oh, beautiful. 0, 11. Great. Now this is something, this last part is something that Desmos can't give you, but you can confirm something. I can confirm that 2 plus the square root of 1/3, oh, that's about 2.577. Oh, nice. We nailed it. How about 2 minus the square root of 1/3? 1.422. Did we get that one right? Yeah, looks pretty good. And of course, Desmos rounded, so it's 1.423, but what it's saying is that we got it right. Now on the exam, I have no problem with you checking your work. I encourage you to check your work. That way you can know if you got it right. But check this out. I mean, it's just showing you pretty much we nailed this. We've got all the right answers here. There's one last thing that I might ask for on a graph like this, and that's the axis of symmetry. That's going to be the line that goes through the vertex. Now it has an equation. If I just type in the number 2, let's see, I don't want to do that there. If I type in the number 2, Desmos doesn't know what to do that. I don't know what to do with that. In order to graph this, I need to tell it a little bit more. So is it x equal 2 or is it y equal 2? Well, if it's y equal 2, that's a horizontal line. What about x equal 2? Oh, there we go. That's your axis of symmetry. That's the line, that's the equation that I need. Please don't give me just 2. I don't know what you mean, neither does Desmos. So give me something a little bit more, x equal 2. Beautiful. That's a 10 or 11 point problem. It's a big problem, but you can chip away and get lots of little pieces on it. You should be able to get the whole thing, especially if I let you use Desmos. Now, using Desmos requires you download the Desmos test mode app. Not just Desmos, but Desmos test mode. That way, you can run Desmos in such a way that I'm confident you don't leave the app and look at something else. Now, I think and hope you can see it's important and how convenient it was to have this in this form. So the last example that I want to do here is reminding you how to put it in this form. On the test, what I do is I separate these problems into 2 different problems. I'll give you one problem where I say, okay, you know what? Let's put this equation in that form. So let's take a look at f of x equals 3x squared plus 6x minus 45. And we're going to put it into the form that I gave you with the last problem. So the first thing I'll do is I'll write this as y equals 3x squared plus 6x minus 45. Not that it makes a huge difference. Then I'm going to move the 45 to the other side. And now I'm going to kind of continue demonstrating something that I started a little while ago, and that is I want you to put in some of the reasons why I do things. Now, a lot of times when I discuss a problem, I will tell you why, but you may not write it down. I have a feeling that all you write down is what I write down here. So I'm going to start writing down things like to complete the square, you need a coefficient. I'm just going to have to abbreviate that on time or space to write it. Coefficient of 1 in front of the x squared term. That needs to be a 1. Oops, sorry, I didn't zoom out enough. So to complete the square, you need a coefficient of 1 in front of the x squared term. I've got a 3 there right now. I need to change that. So how are we going to change that? So that's this part right here. Well, factor out the coefficient of the x squared term. Just the coefficient. There's a tendency that you guys have, because you've been doing these math problems for a long time, to factor out the greatest common factor. That would be a 3 and an x. That's the wrong thing here. You just want to factor out the 3. 3 in this case. So if I factor out the 3, what gets left behind?
The x squared and plus 2x.
X squared plus 2x. Great. That's all we wanted to do, is just factor out that part. So, okay. Let's keep going. Now we got to complete the square. So let's work on that part. Let's see. So the next part here, complete the square. And there's, you know, hopefully a couple familiar operations to do with that. You remember how to complete the square. Complete the square in the parentheses. Remember that part? Stuff we did in section 10.1. It's half of what number?
B,
Half of what?
B, so 2.
Half of 2 equals 1. 1 squared is still 1. So I'm going to put that 1 right there. So a 1 here. But I'm not going to put a 1 over here. What goes over here? Well, let's see. If I put a 1 here, then I'm really adding 3 times 1 to the right-hand side. So I should better add 3 to the left-hand side to keep them in balance. So you see that, how that works? All right. It's a little trickier than a lot of the problems when you have a coefficient of 1 to start with. You're in great shape. Here, because there's a number out in front there, you got to multiply that times whatever you put here. And that's what gets added to the other side. So that becomes y plus 48 equals 3 times something squared. What do you square to get that right-hand side? X plus 1. And finally, I'm going to move the 48 back to the right-hand side. 3 times x plus 1 squared minus 48. Bam. Looking great. Can anyone tell me what the vertex is? Actually, tell you what. Write it down. If you're on Zoom, put it in the chat. What's the vertex? Just by looking at it. Somehow I feel compelled to say dzień dobry. Dzień dobry is good morning in Polish.
My girlfriend said we could go into the store.
Okay. Okay. I'll tell her dzień dobry. You have to change the sign. You have to ask yourself, what do you mean? That is x equal to, so that this whole thing is 0. 1 plus 1 make that 0? No. What would you add 1 to get a 0?
Subtract
or another way to think of it, write x plus 1 equals 0. Solve it. Okay? Not quite. You wanna find the value of x that makes that square term equal 0. So what you're looking for in the value of x is the value that makes the square term 0. Good, good.
Oh, that is.
Mm-hmm.
I was just.
Okay, alright, good. Okay, so the idea here is what value of x makes the squared term equal to 0? In other words, when does x plus 1 equal 0? Melanie, what was your answer on that one?
-1.
-1, good. So our vertex is really at -1 and what else? -48. Alright, so it's a great skill just to be able to read that off. In fact, doing it this way had a little bonus. This value right here, or this part right here, that's the equation of your axis of symmetry. Equation of the axis of symmetry. And then you can go on and do everything else you need to in this problem. You can find excuse me, the X and Y intercepts. Let me just note for you that this and this are totally equivalent. So that if you were asked to find the Y-intercept, you could set x equal to 0 here, or you could set x equal to 0 here. But this is easier to set x equals 0 at. Can anyone tell me why? Why is it easier to set x equal to 0 here as opposed to down here? You'll get the same thing. If I set x equal to 0, this term disappears, this term disappears. What's left? -45. You get the same thing here, it's just you gotta do a little bit more work, that's all. So, I like setting it equal to 0 here, but the cool thing is you got both of these. You can use whichever format of this you want. Top one or the bottom one, as is convenient. In fact, in terms of solving the X intercepts, I'd probably go with this. In fact, I definitely would go with this. Do you want to finish this up? Should we solve for the X intercepts? I think it actually works out kind of nice. So let's do it. So if I had y equals 3 times x plus 1 squared minus 48. If I want to find the x-intercepts, set y equals 0 to find the x-intercepts. So it's going to be 0 equals 3 times x plus 1 squared minus 48. How did we work this last time? What do I do next? Add 48 to both sides, equals 3 times x plus 1 squared. Good. Someone else? Marcel? What else would you do next?
-48.
That would put it back on the other side. How about if we try and get the squared term by itself a little bit more? And right now the squared term is being multiplied by 3. So what would be the opposite of multiplying by 3?
Divide.
Dividing by 3. So it gives me 16 equals x plus 1 squared. Devin, any ideas what I would do here to solve?
Take the square root of both sides.
Awesome, thank you. Take the square root of both sides, and in particular on the left-hand side, I need to remember what? Plus or minus. Thank you both. All right, so it's going to be plus or minus 4 equals x plus 1. Do me a favor, do yourself a favor. Take care of these cases one at a time. Just write out the positive case and the negative case. It's either equal to +4 or -4. But if I subtract one, I get x equal 3. If I subtract one here, I get x equal -5. What you can't do is move this over and go, oh, plus or minus 5 or plus or minus 3. It just doesn't work. You've got to solve those individually. There's your two x-intercepts. We know what the y-intercept is, it's -45. We got the vertex, we've got pretty much everything we need there. All right, let me let you get to work on some of this stuff. If you have some questions, please reach out.